everyone. I welcome you all in this session. As we have discussed the first order linear differential equation in the last session, तो हमने ये देख लिया कि अगर हमारी differential equation इस फॉर्म में होगी dy upon d of x plus any function of x times y is equal to any function of x, तब हम इसका जो सोल्यूशन होगा दैट विल बी y times e integral of p of x dx is equal to integral of q of x, okay, times e integral of p of x dx plus c। तो इस पार्ट को हम इंटीग्रेटिंग फैक्टर कहते हैं, ओके। तो इस तरीके से हम इसका सोल्यूशन देखते हैं। और फिर हमने ये देखा था कि अगर हमारी डिफरेंशियल इक्वेशन, इस वाले को हम कहते हैं लेबनीज लीनियर डिफरेंशियल इक्वेशन, अगर हमारी डिफरेंशियल इक्वेशन इस फॉर्म में हो गई डी वाई अपॉन डी ऑफ एक्स प्लस एनी फंक्शन ऑफ एक्स टाइम्स वाई is equal to any function of x times y raised to power n and is not equal to 1, तब हम क्या करते हैं, इस वाले डिफरेंशियल इक्वेशन को हमने कहा है इट इज कॉल्ड द बर्नौलीज इक्वेशन, इजंट। तो इसको सॉल्व करने के लिए हमने बोला था कि हम इस y रेज़ेड पावर n से इस पूरी डिफरेंशियल इक्वेशन को डिवाइड करेंगे, तो हमारे पास क्या आएगा, दैट विल बी 1 by y raised power n dy upon d of x plus function of x y divided by y raised power n is equal to function of x y raised power n divided by y raised power n. So I will get 1 by y raised power n times dy upon d of x function of x 1 by y raised power n minus 1 q of x। तो हम क्या करेंगे, हम इसको चेंज करेंगे, इस वाले टर्म को इन अनदर वेरिएबल। हम सपोज करते हैं 1 by y raised power n minus 1 is the variable z, so that means y raised power minus n minus 1 is equal to z, differentiate on the both sides। तो जब हम इसको डिफरेंशिएट करेंगे दैट विल बी माइनस n minus 1 y raised power minus n plus 1 and power down power minus 1 and dy by d of x will be equal to dz by d of x। सो ये किसके बराबर आएगा, यहाँ से अगर आप माइनस कॉमन लोगे सो इट विल बी 1 minus n because minus minus will go plus, so it will be y raised power minus n dy by d of x is equal to dz upon d of x। तो ये क्या आएगा, 1 by y raised power n dy upon d of x is equal, तो ये जो लेफ्ट हैंड साइड जो टर्म है इन द मल्टीप्लिकेशन इट विल गो 1 by 1 minus n dz upon d of x। तो हम अब ये जो 1 by y dy upon d of x इसके बदले ये वाली टर्म डाल देंगे, दैट इज 1 by n minus 1 dz upon d of x function of x 1 by y n raised to power n minus 1, that is our z is equal to function of x। सो अब हम क्या करेंगे, इसे मल्टीप्लाई करेंगे n माइनस 1 से थ्रू आउट, तो हमारे पास आएगा dz अपॉन d ऑफ x प्लस n माइनस 1 p ऑफ x टाइम z is equal to n minus 1 into q of x. तो ये जो पार्ट है, ओके, ये जो पार्ट है हमारा, ये हमारा p डैश बन गया और ये हमारा q डैश बन गया. तो ये जो फॉर्म आ गई, दैट इज dz अपॉन d of x प्लस p dash of x z is equal to q dash of x. So it is now in the Leibniz form. So इसका solution क्या होगा? z times e integral of p dash of x dx is equal to integral of q dash of x e integral of p dash of x dx plus c. तो दिस इज द सोल्यूशन. और इस तरीके से हमने एक एग्जाम्पल भी कर ली. सो दिस इज द वे हाउ यू विल सॉल्व दिस बर्नौलीज डिफरेंशियल इक्वेशन. तो आई एम सॉरी, लास्ट सेशन में कुछ मिस्टेक्स हुई थी, तो हमने ये मल्टीप्लाई किया था. एक्चुअली इट विल कम एज ए, ये डिवाइड हो जाएगा. ठीक है. तो इस तरीके से अगर कोई भी क्वेश्चन होगा तो उसको आप ऐसे ही प्रोसेस करोगे. यहाँ पे जैसे हमने ये वाला क्वेश्चन किया था. सो यहाँ पे ओके, सो यहाँ पे जो है हमने इस वाले टर्म को लेफ्ट हैंड साइड ले लिया क्योंकि यहाँ पे y है. तो फिर हमने इस 1/y को पुट किया था. तो इस तरीके से यहाँ पे हमने सॉल्व किया. तो यहाँ पे कुछ मिस्टेक्स हुई थी, दैट यू विल सी. ओके. So now we are going to start the another very important portion of this differential equation, that is the higher order linear differential equations. Okay. As we have seen that what is a linear differential equation, we say that if the dependent variable and its derivative is of first have the power as 1 and they are not in the multiplication, so we can say that dy upon d of x, it is linear. D square y or d2y by dx square, that is also linear. dqy dx cube, it is also linear. And dny dxn, it is also linear, is it? So if I will multiply it by the variable x or by the coefficients, there's a constant numbers. Okay, so constant coefficients, that's 1 2 whatever, so it will always be linear and the sum of these terms will be linear. So we can say in general that the nth order, so the nth order linear differential equation is of the form dny by dxn plus p1 dn minus 1 y dxn minus 1 p2 dn minus 2 of y dxn minus 2 and pn minus 1 dy upon d of x plus pn of y is equal to some function of x. So this is the general form of the linear differential equation, because you can check that each term is linear. Here it is linear, the order is n. This is linear, the order is n minus 1. This is linear, the order is n minus 2. And here the p1 p2 p3, so here pi's will be the constants or the functions of x. So now these pi's, as these are the functions of x, so if we will multiply it with this differential coefficient, so these will be still linear because x is the independent variable. So this is the general form of the nth order, because the highest order is n, so we say that this is nth order linear differential equation. So if the coefficients, if all these pi's, means if all the coefficients of these differential derivatives are constants, so we are saying that it is the constant coefficient linear differential equation of nth order. So what will be that? So we can say that dn y by dxn minus 1 plus coefficient, this will be constant a1, dn minus 1 y by dxn minus 1 plus second coefficient of this one, that is the dn minus 2 by y dxn minus 2 plus so on plus an minus 1 dy by d of x plus an of y is equal to some function of x. So this is the linear differential equation of constant coefficient. So here these ai's are the constants. So this x will be the constant or the function of x. Okay, so this is the linear differential equation with constant coefficients. So before we show that how to solve these differential equations, so I want to just let you know the symbolize of these differential coefficients. As you know that if I will write the dy by d of x, so what is this? It is actually you are applying the operator dy upon d of x with the dy by d of x to the y. Okay, for example, if your y is x cube plus 2x plus 3, what you are doing? So you are differentiating this d by d of x cube 2x plus 3, isn't? So this part, this is the operator. This is the operator. So this operator, we are denoting it by the capital D. We are denoting it by the capital D. So we can say that if we have the dy upon d of x, it is actual d by d of x of y. So now d by d of x, we are just denoting it, symbolizing it by the d. So we can say it is d of y. Similarly, you can say d2y by dx2, that is actually d by d of x of d by d of x of y. So that is d by d of x of d of y, because this d by d of y, that is d. So it is again the differentiation. You can denote it d2 of y. So that is d by d of x, you are denoting it by d square by dx square, that is denoting by d2, d by d3 by dx3, that you are denoting by d cube, and so on. So thus the symbol, this d is a differential operator. These are the differential operator or simply a operator. Okay, so then we can make this one differential, the nth order differential equation. So we can, it means that we can write this one term as the d of n, is it, of y, plus a1, we can write it dn minus 1 of y, plus for this one I can write d a2 dn minus 2 of y, plus so on, plus for this one an minus 1 dy by d of x, we can say d of y, plus an as y here also. With every term there is a y, so I will take it common. So I can write it, it is equal to some, the function of x or the constant. So it means that this term, now ये जो term है इसको हम denote करेंगे, it is equal to the polynomial in D. Since it is a polynomial having the constant coefficients, so this is a polynomial in D times y is equal to some function of x. Okay, so it means that your nth order linear differential equation having the constant coefficients can be written as the polynomial in D, y is equal to x, and this f of d is, so you know, this is just like a polynomial, that is d of n plus a1 dn minus 1 plus a2 dn minus 2 plus so on plus an minus 1 d plus an. This is the polynomial in D, is it? So then what we are doing, so you have to note it here that this operator, as you are as the differential operator, that's differentiation is linear. So similarly, if you have to apply, I will write it here. If you have to apply the d on the two functions u and v, it is same that you will apply d with u and d with v. If you have to apply the differential operator on the lambda times any function u, it is same lambda d of u. If you have to if you have to apply d raised to the power p, d raised to the power q, okay, to some function u, it is same to say d of p plus q of u. Okay, so these differential operators, this d is nothing, it is the symbols of your differential coefficients. Okay, so now how we are solving these nth order differential equations. Okay, how we are solving these nth order differential equations having the constant coefficients. So to solve the differential equation, f of d of y is equal to x, any function of x or the constant. So here we are solving it, its solution, you have to remember the complete solution of this differential equation is the complementary function and the particular integral. So it depends on your RHS. It depends on your RHS. So its complete solution is complementary function only. Okay, so complementary function, its solution is only complementary function when your RHS is 0, and its solution is complementary function plus particular integral if your RHS is non-zero. Now, the question is that what is this complementary function? Since we have to find it in the both cases, so first we will understand what is a complementary function. So consider the differential equation. We consider the differential equation, that is dn plus a1 dn minus 1 plus a2 dn minus 2 plus so on an minus 1 d plus, okay, an of y is equal to 0. Okay, so first we consider, let x is equal to 0 and I consider this differential equation. So for x is equal to 0, for the x is equal to 0, so what we are doing, we are finding the auxiliary equation, or if it is non-zero as well, then we are supposing it to be the 0. Clear? For the complementary function. So now the question is, what is the auxiliary equation of this? So the auxiliary equation for a differential equation having the constant coefficients is, just make it a polynomial, as this is a polynomial in the operator d, just make it a polynomial of m, any value m. So that means its auxiliary equation will be equal to m raised to the power n, a1 m raised to the power n minus 1, a2 m raised to the power n minus 2, okay, plus so on, plus an minus 1 m plus an is equal to 0. This is the auxiliary equation, means changing the d into the, so as this is a function of d, y is equal to 0, so make this as a polynomial in m is equal to 0. Then find the roots of this, means find the values of m, as it is of the nth degree, means it has the m roots. Okay, so this is the auxiliary equation. auxiliary equation. Okay, there's a mathematics behind it. For in your syllabus, we have only the rules through which we can find the complementary function. Otherwise, there is a mathematics behind it. We have to check the if there is a solution. The linear combination of the solutions is also the solution, and then we will go through the auxiliary equation. We are putting the solution is e raised power mx, and then we have to proceed it. Okay. So, what is the auxiliary equation? It is the equation obtaining by equating to 0 the symbol coefficients of y, that is the d. Okay. So now, why we find this auxiliary equation? We find it only to find the solution of the complementary function of the differential equation. Okay. Now there are the cases. If this polynomial p of m is equal to 0, if it has the real roots only, the first case, if it has the real roots, and every real root is distinct. That means, for example, it has the n roots. It has the n roots because its degree, the polynomial has a degree n. So I suppose it has the n roots. So it has a root m1 that's not, let's say, equal to m2, that is distinct from m3, that is distinct from all the roots are distinct and they are real. Then you have to note its complementary function will be equal to c1 e raised to power m1x plus c2 e raised to power m2x, c3 e raised to power m3x plus cn e raised to power mn x. This will be the solution. And you, as I told already, the number, that's the order of a differential equation. Whatever the order will be, that number of the arbitrary coefficients will be there, and you can check its order is n and its coefficients will also be n in the complete solution. So this is the complete solution when you have the real roots and it is distinct. Now, if the polynomial have the real roots but some are same, For example, real roots and some are same. For example, I will say m1 first root is equal to the second root. Let its value is k. Okay. For example, m3 root is equal to the m4 root is equal to the m5 root is equal to the some beta, and then m6 is not equal to m7 is not equal to m8 is not equal to so on mn. Okay. So then what is a complementary function? So in this case, the complementary function find the equal roots, that is m1 and m2. So you will write c1 plus c2 of x e raised to power what is the same root k of x plus now m3, m4 and m5. Three roots are same, so I will write c3 plus c4 of x c5 of x square. Three roots are same, so e raised to power beta x. Then after they are distinct, so I will write c6 of e raised to power m6 of x, c7 of e raised to power m7 of x, and plus cn e raised to power mn of x. So these are the roots of the polynomial p of m. Okay, clear? So this is the complementary function for the roots if they are real and equal. Okay. Now, if the roots will be complex, okay, if the roots will be complex, they are coming as a conjugate. So now, as if we have the roots as the complex roots, so for example, if as I told, if there will be the m roots, let's say we have the m1 m2, okay, the complex roots. So there will be the m1, m2, m3, m4, m5, and so on up to mn. So let's say as the complex roots are coming as a conjugate, so we will say it will be alpha plus minus iota beta. Okay, so then let's say m3 will not be equal to m4, that's not equal to m5, that's not equal to mn. So let these all roots are real, and these two are complex, that's m1 and m2. So m1 is positive alpha plus iota beta, m2 is alpha minus iota beta. Okay, so what is a complementary function? So for these roots, these are real, so the complementary function is as it is, we have discussed it above. So for this complex one, what we are doing, we are taking the e raised power the real part, that is the alpha x, okay, times the c1 cos of the complex part, that is the beta of x, plus c2 sine of beta x. Then plus for these c3 e raised power m3 of x, okay, c4 e raised power m4 of x, and so on, plus cn e raised power mn of x. Okay, so if for example we have the roots in this form, for example we have the complex roots and the roots are same. For example, I will say you have the alpha plus iota beta is m1 comma m2. So do two roots, that's alpha plus iota beta and alpha minus iota beta, these are the two roots. And let's say m3 and m4 is same, okay. And then let we have the only four roots, or you can say m5 is not equal to m6 is not equal to, and so on up to the mn. These are for example the real roots. Okay, so what we will do, as we have the four roots here and both are the complex roots, that is alpha plus minus iota beta is two times. So what we will do, the complementary function will be here, as it is coming the two times. So I will write it e raised power alpha x, then c1 plus c2 of x cos of your imaginary part beta of x, c3 plus c4 of x sine of beta x. And then similarly c5, let's say these two are same, m5 and m6 are same, others are not, that's not equal, that's distinct. So I will write c5 plus c6 of x e raised power, let's its value will be something eta, so that will be eta of x, and c7 e raised power m7 of x, and so on. Okay, so these are the ways how we are writing the complementary function. For example, if I will give you one differential equation in this way, 9y triple dash, that is the third derivative, plus 3y double dash minus 5y dash plus y is equal to 0. So first we will symbolize it in the d. So you know this is the third derivative, this is the second derivative, this is the first derivative. So we can make it as symbolize y d cube plus 3 d square minus 5d plus y is equal to 0. Then the auxiliary equation will be 9m cube 3m square minus 5m plus 1, because this you can write 9, sorry, this one is the 1, this one. Okay, so this one you can write it as to be the 0. So now you have to make this one, you have to find the values of m, as this is the cubic equation. So if you will see that m is equal to minus 1 is the root of this one, means that p of -1 is equal to 0. If you will put the -1 at the place of m, you will see that that will be the 0. So then what will you do? Take this minus m with the LHS, so it will be m plus 1. Divide this, that is 9m cube plus 3m square minus 5m plus 1. Divide it with the m plus 1. You will get a quadratic equation here. Find that roots by the quadratic formula. You will get the roots. So in short, the m plus 1 will be one factor, and 3m minus 1 whole square will be the another factor. So that is m is equal to -1, and m is equal to 1 by 3, and again 1 by 3. Okay, why? Or if you will not get it, so when this is equal to 0, that is m plus 1 is 0, or 3m minus 1 whole square is equal to 0. That is 3m minus 1 is equal to times 3m minus 1 is equal to 0. That is 3m minus 1 is equal to 0, or 3m minus 1 is equal to 0. So from this, m is equal to -1. From this, m is equal to 1 by 3, and from this, m is equal to 1 by 3. So you have seen you have the three roots here. Let it will be m1, this is m2, this is m3. So your complementary function will be equal to c1 e raised to power your one root, that is -1x, so that is minus x, plus c2, and you can see that these two roots are same, so I will write c2 plus c3 of x e raised to power 1 by 3 of x. So I write this because the roots are same. So now as you can see that its RHS is 0, so its complete solution is only this function, that is the complementary function. Okay, so when your RHS is non-zero, then we have to find the particular integral as well, so that we will discuss in the next session. Please do the practice to the questions, and that will be beneficial for you. And for example, I will give one more example here, that is for the last case when you have the two equal complex roots. For example, I will give one example here. Okay, so for example, d4y by dx4 plus 4x is equal to 0. You have to solve it. Your RHS is 0, means complete solution will be only the complementary function. So I will symbolize it. So it will be d4 plus 4. So it is y. So it is y is equal to 0. So its auxiliary equation will be m4 plus 4 is equal to 0. Yes or no? So we can write this as m4, so, or I will write it in this way, m square whole square 2 whole square. Now 2 times this m square times 2 minus 2 times m square times 2 is equal to 0, is it? So for this one, this is a plus b ka whole square, so I can write m square plus 2 whole square minus 2, 2 to our 4 m square. Yes or no? 4m square is equal to 0. So this I can write m square plus 2 whole square minus 2m whole square is equal to 0. Now you can use the formula a square minus b square, that is a plus b, so m square plus 2 plus 2m, and a minus b, m square plus 2 minus 2m is equal to 0. So now you have the quadratic formula here. This is the uh, quadratic polynomial. So here the second one is as well. So if you will find the value of m here, so m will be minus b plus minus root of b square minus 4ac. So you will get it that is -2. So -2 plus minus root of 4, that's -4 by 2, and another case you will get 2 plus minus root of 4 divided by 2. When you will solve it, you will get the -1 plus minus iota, and here you will get the 1 plus minus iota. So now the two complex roots are different. So your m1 and m2 is here, m3 and m4 is here. So the complementary function for this one will be the real part is -1. So you can write e raised to the power minus x c1 cos of beta. So 1 times iota. So 1x plus c2 sine of 1x. Plus now for this one, so you have the 1 times x because your real part is 1. So that is x. c3 iota times 1. So that is c3 cos of 1x plus c4 sine of 1x. Okay, so this is the solution, that's the complete solution for your given differential equation. Because your RHS is 0, so this is the complete solution that we are calling it as a complementary function. Okay, thank you very much. See you in the next session.